Hello everyone, welcome to this video on section 3.1. Here in this part of the course we're doing descriptive statistics, which if you remember is learning how to describe different characteristics or different features of our data set. Today we're going to be looking at how we can describe the center of a data set or the middle of a data set. And there's four different ways that we can look at the center of a data set, and we call these the measures of central tendency. So one of the ways that we can talk about the middle of the data set is with what we call the mean, or sometimes it's called the average. Now, in order to calculate the average, what you're going to do is you're going to add up all the numbers in the data set and then just divide by how many numbers are in the data set altogether. If you're working with sample data, the symbol that you're going to use to represent the sample mean is X bar. Okay, so this X with a bar over it would be a sample mean. And you can see the formula here. This symbol that I've highlighted here, that's Greek letter capital sigma. Whenever you see that symbol in a mathematical formula, it just means you're going to add up a list of numbers. Whatever comes after that symbol is the list of numbers that you're going to add up. So here where we have sigma x, that means we're going to add up all of the x values. And x represents our data. So just add up all the data values and divide by n. N represents the sample size, which would be the number of numbers in our list. When we work with population data, the symbol that we use to represent the population mean is the Greek letter mu. It looks like our letter U, but it's got that extra line on the front. And it's really the equivalent of the letter M in the Greek alphabet. It's the letter mu, MU in the Greek alphabet. That's the population mean. And you can see that the formula is very similar. We add up all the data values and then divide by the population size. Notice we use capital N to represent population size, lowercase n to represent sample size. Okay, so you add up all the data values, divide by the number of numbers that are in that list, you get the mean. That's going to tell you something about the center of the data. Another way that you can talk about the center of a data set is with what we call the median. So the median is going to be the middle value when the data is in order. In other words, it's the value that occupies the middle position in the data set whenever the data is sorted from lowest to highest or highest to lowest. The mode is the most frequently occurring value. Sometimes there's more than one mode in a data set, so that's why I have the little parenthesis S there. And then the mid-range would be the number that is exactly halfway between the minimum and the maximum. So to find that, you would take the minimum plus the maximum and divide by 2. And of course, that's going to tell you about the center of the data set just because it's halfway between the minimum and maximum. Okay, so here's an example data set where some data was collected from a sample, and we're going to calculate these measures of center for this data set. So the first thing I did is I just sorted the data so that it's in order. That's going to be helpful when it comes time to do the median especially, okay, but it's also helpful for some of the other calculations as well. In order to find the mean of the data set, we're going to add up all these numbers. So take 5 plus 5 plus 6 plus 7 plus 12 plus 14 plus 16, you get 65. And since there are 7 numbers in the list here, we'll divide by 7. And that gives us 9.3. Okay. As far as rounding this value, because when you put it into your calculator, you're not going to get 9.3. It's going to be 9 point, and there's going to be a whole bunch of decimal places that follow. The rule of thumb is that if the data is whole numbers, our descriptive statistics will get expressed with 1 decimal place. So that's why I'm using 9.3 here for my answer. Now you can see 9.3, that's, more or less in the middle of the data set. One way that you can really think about the mean being the center of the data set is if you think of a number line. Okay, so let me draw a number line in here. And let's say that we were to, start this here at 5, then we would have 6, 7, 8, 9. This will be 10. And then we'll have 11, 12, 13, 14, 15. And then 16, 17, 18, 19. And we'll go ahead and finish up here at 20. If I were to take a little weight, let's say like a 1 ounce weight, and everywhere a number shows up in the data, I put that weight on the number line. So, okay, so we have the number 5. So I put a little 1 ounce weight there. And then we actually have another number 5. So I'm going to put another 1 ounce weight at 5. And then we have the number 6. So I put a weight there. I put a weight at 7. I'm going to put one out here at 12, one at 14, and one at 16. So it's almost like a dot plot, but just think of the dots as like 1 ounce weights. If we wanted to balance this number line, okay, so if we wanted to find the balance point, the mean would tell us where the balance point is. Okay, so the balance point would be at 9.3, which would probably be somewhere right around here. So you could put a little balance point there, and that number line would stay perfectly level. You might call it a center of gravity point. So that's how it's describing the center of the data set. It's like a center of gravity point. Okay, so that's the mean. The median is the number that occupies the middle position when the numbers are in order like this. If the numbers aren't in order, the number in the middle position is just going to be some random number. But when the numbers are in order, the number that's in the middle position, which in this case is the number 7, tells us something about the middle of the data set. Okay, so notice that there's 3 numbers on either side of the number 7. That's how I know the number 7 is the one that splits this list exactly in half. The mode is the most common value. Notice the number 5 shows up twice. Nobody else shows up 2 or more times, so the mode is 5. Now the mode, if you notice, doesn't really describe the center of the data set very well in this case. Sometimes the mode describes the center of the data set, sometimes it doesn't. Okay, the reason that the mode gets included as a measure of center is because there's a kind of data called normal data. We're going to learn a lot more about this later in the course. But normal data is basically data where if you made a histogram, you would get some kind of shape like this for your histogram. Okay, this is just kind of a rough sketch of a histogram here, but imagine that's a a nice, neatly drawn histogram. If you can take what we call a bell-shaped curve and place it over the bars of the histogram, then you have normal data. And when you have normal data, the mode will come from the center of the data set most of the time. Okay, notice the big bars here in the middle of the data. That means most of the numbers are in the middle, so you're likely to get a lot of repeats in the middle. And so you would end up with the mode somewhere in the middle. But we don't have normal data in this example, so that's why the mode didn't really describe the center of the data set for us. And then the mid-range, minimum plus maximum divided by 2. So 5 plus 16 divided by 2, that gives you 10.5. Like I said, that's the number that's exactly halfway between the minimum and the maximum. So if you think of our number line again, if we have the number 5 on one side, that's the minimum. Okay, it's number 5. And then if we got 16 on the other side, the mid-range, which is 10.5, would tell you the number that's exactly halfway in between. So of course that tells you about the middle of the data set in its own way, along with these other measures. Now, the way I like to think of these 4 measures is I like to think of them as 4 different people who went to the museum and they looked at a painting. If you and 3 of your friends went to the museum and you all looked at the same painting and somebody came back and said, describe what the painting was about, each of you would describe something slightly different. Okay, you each kind of look at that painting from your own unique perspective. Well, that's kind of what these 4 measures are doing. They're all looking at the center of the data set, but they're all looking from their own perspective and describing it in slightly different ways. So we have the mean, the median, the mode, and the mid-range. Let me do one more example here with you, just for practice. So again, this is some data that came from a sample, and this data is already sorted in order. If it wasn't, I would probably do that first. It's necessary when you find the median, but it's also helpful for some of the other calculations. If you find the mean, you add these numbers up. If you add them up, you should get 30. And this time there are 6 numbers in the list, so take 30 divided by 6, and you get 5. Now remember the rule of thumb, if the data is whole numbers, we probably want to express our descriptive statistics with 1 decimal place, so I'll call it 5.0. Now in this case, if you want to find the median, you got to try to find the number that's in the middle position. Notice the number 5 does not do the job. Okay, there's 2 numbers to the left of it and 3 numbers to the right of it. The number 6 does not do the job. 3 numbers to the left, 2 numbers to the right. If you want to split this list in half, what you actually have to do is you have to box off the 5 and the 6. Now you have 2 numbers on either side of your box. Whenever there's an even number of numbers in the data set, this kind of thing will happen. What you do is you box off the 2 numbers that are in the middle, add them up and divide by 2. So 5 plus 6 divided by 2 is 5.5. We'll call that the median. Notice in this case, the number 3 shows up 2 times and the number 6 shows up 2 times. Nobody else shows up more than 2 times, so 3 and 6 are both considered modes. Now, if we had another number 3 in the list, so let's say the data set actually had another number 3 over here, then only the 3 would be the mode because it would be showing up more often than the 6. Okay, but that's not the case here. Both numbers showed up twice. Nobody else showed up more than twice, so 3 and 6 are both modes. By the way, if all the numbers in the data set show up 1 time only, then there is no mode. You would just say no mode. In the mid-range for this one, we have the minimum 3 plus the maximum 7, which is 10, divided by 2, and that gives you 5. Okay, so looking at the measures of center here, especially the mean, median, and mid-range, because again, I'm not so sure we have normally distributed data here, but mean, median, mid-range, you get a pretty good idea that the center of this data set is somewhere around 5. Okay, and that seems to be the case when you look at the numbers. Okay, now let's look at another situation. Okay, something called a weighted mean. So when you're calculating the mean, remember one way I said that you can think about the mean is you put these like little 1-ounce weights on the number line. Well, there are going to be some situations where some numbers in the data set should be given more weight and some should be given less weight. And a prime example is in a lot of your classes, like this one, when you get the syllabus, it'll tell you about the different kinds of assignments that you have in the class, and it'll say that each of those assignments is worth a certain percentage of your overall grade. So for example, 50% of your grade might come from the test, 15% from homework, 10% from the project, 25% from the final exam. So in cases like this, if you want to calculate your grade, you can't treat the score you earn in each category equally because you've got these weights that are saying you should give more emphasis to some of your scores and less emphasis to others. When you have this kind of situation where you've got a list of numbers that you want to average, but some are considered more important and some less important, you'll need to calculate what we call a weighted mean. So a weighted mean, you can see my formula over here for the weighted mean, is going to be the sum of each weight times its corresponding data value divided by the total amount of weight. So let me show you how this weighted mean might work in a calculation for a class like this. Okay, let's say that we were having 4 tests throughout the semester, and each test counted equally towards that portion of your grade. So you earned scores of 84, 76, 92, and 78. To get your test average, I might just take a regular plain old average of these 4 tests, add them up, divide by 4. That gives me 82.5. Okay, all 4 tests count the same for the test portion of your grade, so I can just do a regular straight up average there. Homework, let's say there were 6 homework assignments. Each homework assignment counts equally towards the homework part of your grade. So again, I can just take a straight up average here, add them up, divide by 6. I get 97.0 for the homework grade. The project, let's say that's just a one-time assignment, 93, and the final exam, a one-time assignment, that's 70. If I want to calculate your overall grade in this class, what I'm going to do is I'm going to make a little chart like this, where I've got the test, the homework, the project, the final exam, and I'm going to list the amount of weight associated with each category. So these are those percentages. I just put them in decimal form. And then I list your scores. Your test average was 82.5, your homework average 97, project 93, and final exam 70. Now to calculate the weighted average, I have to take each weight times its corresponding data value. So for the test, 0.50 times 82.5 gives me 41.25. For homework, 0.15 times 97.0 is 14.55. For the project, 0.10 times 93 is 9.3, and the final exam, 0.25 times 70 is 17.5. So I can add those numbers up, which gives me 82.6, and then divide by the total amount of weight, which in this case adds up to 1. So 82.6 divided by 1 is still 82.6. So notice the effect that the weight has on the grade. If you were to just take your 4 scores here, the 4 X values, and then just take a regular average for these, add them up, divide by 4, your grade would be 85.6. Okay, but because the test and the final exam carried more weight, they brought the result closer to them. So that's what brought the score, the average, down from an 85.6 down to the lower 80s. It's because your test and your final exam carried more weight, and so they're kind of pulling the average closer to themselves. Okay, one last thing from this section that I want to go over with you in this video, and it's how we can estimate the mean from a frequency distribution. Okay, so remember in our previous video, we had some data that was collected that was the ages of students in a MAT107 class. You might remember this data from the Chapter 2 video, the ages of students in a MAT107 class. And we organized that data into a frequency distribution. Let's say that you were working on a report for your class and you had the data on one page and then you made the frequency distribution on another page. And then you come back the next day and your plan is to calculate these measures of center and add them into your report. But when you come to your notebook, what you find is that somebody tore out the page that has all the data. Now you still have the page with the frequency distribution on it, but you've lost all your data. So how are you going to come up with the measures of center when you don't have the actual data? Well, you're not going to be able to come up with exact values for the measures of center, but you can still estimate at least the mean of the data set from your frequency distribution. Okay, so here's our frequency distribution. Remember our class limits and our class midpoints and our frequencies. We calculated those in the previous video. If you want to estimate the mean of your data set using this frequency distribution, treat the class midpoints as the X values and the frequencies as the weights. And then just multiply each weight with the X value. So 17 times 20 is 340, 6 times 27 is 162, 5 times 34 is 170. Okay, so just multiplying each weight with the X value, which is the midpoint, and add that column of W times X values up. In this case, that's 1197. Divide it by the total amount of weight, which is the total of this frequency column, that's 40, and you end up with 29.975, which is approximately 30. Basically, what you're doing here is you're saying, okay, I know there's 17 numbers in the data set that are between the number 17 and 23. I don't know exactly what those numbers are, but 20 would be my best guess for them. So you're essentially putting the number 20 in the data set 17 times. And then you say, I know there's 6 numbers between 24 and 30. I don't know exactly what they are, but 27 would be my best guess. So I'm going to put the number 27 in my data set 6 times. And then for the 5 numbers that were between 31 and 37, you would say my best guess is 34, and you'd put 34 in the data set 5 times. If you added all those numbers up and divided by 40, that would be an approximation for the mean. That's essentially what this weighted average calculation is doing when you apply it to a frequency distribution. Now, how good is the estimate? Well, if you were to go back to the actual data and actually add up the 40 numbers in the data set and divide by 40, the average is 29.2. So your estimate of 30 is a pretty reasonable estimate here. Okay, so those are some of the highlights from Chapter 3.1. In our next video, we'll talk about the next section, which is 3.2.